In this video, we'll be continuing talking about hypothesis testing, and particularly we'll be talking about the basics of t-tests. There are a few different kinds of t-tests, and most of this information applies to all t-tests, and all of this information will apply to both the dependent and independent t-test, which we'll be focusing on. We'll also talk about estimating population variance, and we'll see that this estimate of population variance is a variation of the sample variance formula that we learned in an earlier video. Particularly, we'll be using these estimated population variances because we'll see that in the t-test, we don't actually know what our population variance is, and so this estimate will become necessary. Let's get started. And so we're still doing hypothesis testing. So these 5 steps of hypothesis testing are still going to stay the same. And what we know is that really we said that just as we go through different processes, some steps will change. And we saw that even moving from the z-test with 1 person in our sample to the z-test with more than 1 person in our sample. And now we're going to see moving into the t-tests, we're going to have some things change again. And so we're going to pay special attention to steps 2, 3, and 4. And we know that steps 1 and 5 are always going to be the same when we're hypothesis testing. But again, we're going to pay special attention to steps 2, 3, and 4. And in our next lesson, we'll go through this entire process, specifically looking at dependent t-tests. And after that, we'll talk about independent t-tests. But so again, right now in this lesson, these are just the basics. This is some background. So when we go through this whole process of hypothesis testing with a t-test, it'll feel a little bit more natural and a little bit more familiar. So in general, when we think about the basics of t-tests, we know that our first question is always going to be, when we have a new test, when do we use this new test? And specifically, we're going to use a t-test when the population variance and the population mean is unknown. We know that the thing that marked a z-test, those tests that we already did, when we talked about the z-test, we know that those z-tests, we ran those z-tests because we knew our population mean and variance. But we said that that's actually a really rare situation. And so when we don't know our population variance and population mean, more than likely, we're going to be using a t-test instead. And so this is when we're going to be using this particular kind of test. And so we're not going to have our population mean anymore. We're not going to have our population variance. Those will no longer be given, but there's going to be things that we're going to have to do. We're still going to have to figure out what our comparison distribution information is. And so part of that's going to be making, based on some assumptions and making an estimate actually, particularly for our variance. And so for our variance, we're going to make an estimate here. And so we know from early on in the course when we talked about central tendency and variability, we know that based on our sample, based on just the numbers that were given in our sample, we can get the variance of our sample. Now, what we need is our population variance. And in this case, it's unknown. We can imagine in this case, no one, it's not just that we don't know it, no one knows this. This information isn't available. But so what we're going to do in our t-tests is we're actually going to estimate the population variance based on the variance of our sample. And so we're going to really think back to the formula we used in the beginning of the course for sample variance. And we're actually just going to tweak it just a little bit in order to now make this, instead of looking at our sample variance, to make this an estimate. And so it's going to be a really similar formula, but it's going to be just a teeny bit different. And so we'll pay attention to that one special difference. So thinking about estimating population variance here, the idea of this is to get an unbiased estimate. And so if we just get our sample variance, that gives us an idea maybe of what our population variance might be like. But the problem is that that gives us essentially a biased estimate. And so that's not going to be as helpful for us. And so what we're going to do is we're actually going to, you can see that we have this different symbol here. Instead of SD, we have this just capital S squared. We know it's squared because we're talking about variance. This capital S is showing us that this is the estimated population. And then again, squared is the variance. And so this is telling us that it's estimated based on our sample. But we're talking about this estimated population variance. And if you look at the top of this formula, this is going to look really the same. So to review, this is our slide from before when we talked about sample variance. And we can see that when we talked about the sample variance, we had the sum of x minus m squared all over n. And if we go back here, what we see that we have is the sum of x minus m squared all over n minus 1. And this n minus 1 is specifically referring to something called the degrees of freedom, which is often abbreviated as DF. We'll talk about that a little bit more in our next lesson, but I'll introduce the topic towards the end of this video. So we have this procedure that we went through with our sample variance, again, back in the beginning of the semester. So this is just a review slide here, but we subtract, we square those deviation scores, we add up those square deviations, and then divide. And we're basically going to go through those same exact steps now, but instead of dividing just by n, we're going to subtract n minus 1 and then divide by that number instead of just n. And so this is going to be, again, really similar to what we did in the beginning of the semester. And we just want to make sure that we keep in mind moving forward what formula we're using, when to use that formula. And whenever we're estimating our population variance, this is what we want to use. And so we'll be using this with both of our t-tests. And again, paying special attention also to this changed symbol here. And so how do we do this? So going through, again, kind of refreshing our memory about this procedure and making this little tiny change at the end of it. So what we're getting here is we're going to, if we need to, we're going to calculate our sample mean. And then we're going to subtract the mean from each of those scores in our sample. That gives us our deviation scores. We're going to square each of those deviation scores. So after we subtract whatever that answer is in our subtraction, we're going to square that number. And so we're going to do that for each of those numbers that we have. We're then going to add up those answers of what we squared. And then we're going to divide the sum of the squared deviations by the number of scores in our sample minus 1. And again, that's that change, is that minus 1. And so let's practice here. So if you want to take a stab at this, you can write down these numbers and start figuring out that estimated population variance based on those instructions. You can pause that here, or you can follow along. And again, feel free to kind of pause along the way if you want to follow along so I don't get too much ahead of you as you're working out that problem. And so here what we're seeing is I have each of those scores, 788, 731, 6938, this first column of scores. I like doing this the long ways. It's a little bit easier for me. And we got the mean of these scores, which we had is 6. And so I'm going to subtract that mean from each of these scores. And that's going to give me my deviation scores. So my answers here, these are those deviation scores. And I've highlighted here which part of the formula that we're using. And so the first thing we do is what's in those parentheses, that x minus m. The next thing that I'm going to do is I'm going to square those deviation scores. And so I've just kind of spread this out a little bit more here. So we have the same subtraction to the left here, those deviation scores, and now we can see that I've added that square to do that next step, and we can see that I've highlighted that part of the formula now. So we have now x minus m squared, and here are my answers once I do that squaring. And so next thing, now that I have these answers, now what? Now I have to add them up. And so again, I've highlighted in the formula here, now including that x minus m squared with that capital sigma, that sign that means the sum of. This kind of looks like a bit like an E. And so once I add up these squared deviation scores, I get 66. Now we're at the last step here. So our whole formula is highlighted now. We're focusing on this dividing by n minus 1. And so I'm going to divide. We have 10 scores here. 1, 2, 3. All right, let me go back to my original sample scores here on the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Dividing by 10 minus 1. So 66 divided by 10 minus 1 equals 66 divided by 9 equals 7.33. And so this is just the step of estimating our population variance. And so what we're going to see is that this is now going to be part of the process for our t-tests, for both kinds of our t-tests. This is going to be part of the process for getting step 2, in our step 2 information, for getting the characteristics of our comparison distribution.